Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides an introduction to continuous probability distributions by describing density curves. Let's get started. So a density curve is nothing more than the graph of a continuous probability distribution. Now, continuous probability distributions are somewhat different from the probability distributions that we've seen in previous mini-lectures. Those that we've seen in previous mini-lectures, for example, the binomial probability distribution, are what we call discrete probability distributions. And so if you look at the graph, you'll notice that you've got these straight lines going up, and that's because we're having a distribution of discrete data. Remember, discrete data are just the integer whole number of values that we see here. So there's nothing in between the numbers that we would normally be counting. That's discrete data. And so when you have discrete data forming a discrete probability distribution, you get something that looks like this, where you've just got straight lines over the individual values for your discrete data. Contrast that with a continuous probability distribution, where you've got continuous data. So not only do you have the same whole number of values that you would see in discrete data, but you've got every value in between. So instead of seeing a graph where you've got straight lines going up and down, now you've got a straight continuous curve with solid areas underneath the curve being shaded. Whereas here in the discrete distribution, you've only got selected lines from your discrete probability distribution that are shaded. So a density curve is simply this continuous curve that you see here that forms the continuous probability distribution. Now, in order for a curve to be a density curve, it's got to satisfy certain properties. The first is that the total area under the curve must equal to 1. This is important because it plays into something that we're going to be using here, and I'll explain momentarily. The second is that every point on the curve must have a vertical height that is 0 or greater. In other words, you'll never see a negative value for a density curve. It will never fall below the x-axis. It will always be above the x-axis. And this total area here underneath the curve is going to be equal to 1. That's going to be very useful, because when that area underneath the density curve is equal to 1, and it has to be in order to be a density curve, then that creates a direct correspondence between area and probability. Remember, probability, the values for probability are bounded between 0 and 1. So if the total area underneath the density curve is equal to 1, that means any portion of the area underneath the density curve is between 0 and 1. And therefore, we can correlate, or correspond rather, the area that's shaded underneath the density curve with a certain probability. This property is going to prove very, very useful in future mini lectures. So I'm just giving you a little introduction to that right now so you know what's coming. But yeah, it's on the way, and this is one of the most useful tools that we have in our statistics toolbox. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.